when I was asked by Professor Lee, president of KICHE, to prepare myself for the lecture, the title given to me by him was The Progress of 40 Years and Perspectives of KICHE. So I was supposed to review briefly the history, the past history of KICHE, and also explain briefly about the future of this. While preparing materials for the lecture, I realized that explaining about KICHE independently from the development of the Korean society is not possible because the Institute has grown to the present status based on a close relationship with the chemical industries and the universities of Korea. So I thought that I should expand the scope of my lecture a little bit so that I can cover the development of chemical engineering in Korea instead of covering only the institute. So the title of my talk will be Evolution and Growth of Chemical Engineering in Korea. Right? Well, the chemical engineering has played a very important role in the development of the Korean society. And so did the KICHE, and also the education in chemical engineering in Korea. The Seoul National, actually, when I prepared my materials, the presentation materials were prepared by myself, but I should acknowledge that the materials were mostly taken from the publications, materials published by Professors Jason Lee and Hwa-Yeon Lee, who used to work as professors at my department and are now the emeritus professors of this university. Seoul National University is the first modern-style university starting the high-level education in Korea after the World War II. And the Department of Chemical Engineering was one of the early departments that started together with the university. But when we studied the Seoul National University, can I have the next one, please? Next slide. The Korean society was never industrialized country. Because most of the few industrial facilities constructed by Japan were located mostly in the northern part of the country, and the southern part remained mostly as an agricultural area. So this table shows that the first three plants, these are the fertilizer plants of Korea when we were liberated after the World War II. And first three plants were located in northern part, and they covered most of the fertilizer production at the moment. And the south remained as an agricultural area, as I said. So it's a little bit ironical that most of the fertilizer were produced in the northern part, while the agriculture was done mostly in the southern part. Anyway, that was this is just typical status of the Korean industry about 45 years ago. But anyhow, the university started the chemical engineering program, but the education in the chemical engineering at that time, given by the professors of Seoul National University, was not the same curriculum as is done at the moment now in the modern days, nor were similar to the contemporary curriculum made in other countries at the contemporary period. Can I have the next one, please? These are the professors of the Department of Chemical Engineering of Seoul National University. between 1946 and 1950 who educated so-called chemical engineering at this university. But as you see, most of the major areas of these professors were rather close to, say, industrial chemistry or applied chemistry instead of the chemical engineering that we know now. There were two professors who were teaching the subjects close to the chemical engineering. One was Professor Park. He was from the industries, and so his career was mostly at the industry. His curriculum was close to the design and the utilization of the apparatus instead of any of these chemical engineering principles. And Professor Chanson Lee, who is one of the co-authors of this lecture, he was the one who realized the importance of this chemical engineering education, and he was the one who started teaching subjects such as separation processes and process optimization and so on. So this was the starting of chemical engineering education in Korea about 50 years ago. And then Professor Lee played a very key role, a very important role in adapting this discipline to the education of chemical engineering department. Can I have the next one, please? And then he finally succeeded in adding more subjects to the education curriculum of the department. This is the curriculum of 1959. As you see, there are a few subjects that are related to chemical engineering, but still, many subjects remain to the applied chemistry or industrial chemistry. So you may be a little bit surprised to see that there were subjects like explosives or rubber or silicates as an independent subject, because I think that was because that was the major interest area of a few professors. Anyway, it took about more than 10 years to increase the number of subjects related to chemical engineering at Seoul National University. And simultaneously, a few young scholars started to formulate societal membership, or they started the societal activities in chemical engineering. But up to this period, most of the activities were limited within the boundary of the Korean Chemical Society, because these scholars were the members of Korean Chemical Society, and there was no society related to the chemical engineering. Can I have the next one, please? And then finally, in 1962, a group of a few young scholars related to chemical engineering decided to establish the Korea Institute of Chemical Engineering. This is the inaugural general meeting held in 1962, December of 1962. This was the starting of this KICHE. Can I have the next one, please? This decision was a little bit a very timely action, because this was almost the period that Korea started to develop its own economy based on a very ambitious and aggressive economic development plan under the initiation of the Korean government. So this tells us how the fertilizer plants were constructed over about 20 years since 1961. The size of the urea plant was very large, and the government believed that the essential part of economic development of Korea should be based on chemical and heavy industries. So there was a very much emphasis on the establishment of modern chemical industry in Korea during this period. And that gave a very good justification to expand the education in chemical engineering, as well as the societal activities of Korean Institute of Chemical Engineers. Can I have the next one, please? This is another table showing how the refinery or petrochemical industry has been expanded through about 20 years during this period. The first refinery was constructed and completed in 1964. The size of the refinery was not impressive. It was rather small, but it was expanded to larger size. And then in 1972, the government decided to construct a petrochemical complex at Ulsan area, which is the area of SK Corporation at the present time. They started with about 105,000 tons of ethylene production per year, but it was expanded to 155 kilotons per year in about 3 years, because the demand for these petrochemical products were exploding. So the government had to meet to this demand. And also in 1979, they constructed another large petrochemical complex at Yeocheon area. So in about 1980, we had about more than 500 tons of ethylene produced per year. And then in 1984, they started to expand the capacity again. So following this kind of expansion, the economy of Korea expanded also, and so did the activity of the Korea Institute of Chemical Engineers. Can I have the next one, please? In parallel with this kind of progress or expansion in chemical engineering or chemical industries, the curriculum of chemical engineering departments in Korea also changed. By 1975, this is the curriculum of chemical engineering at this university, Seoul National University. Most of the subjects taught at this department are almost the same as those taught in any of these chemical engineering departments, either in America or in Japan. So we had the well-known chemical engineering curriculum in 1975. So this established a very firm ground for the education of chemical engineering at universities. Can I have the next one, please? And KICHE also expanded its own activity. Since the inauguration in 1962, they published the first academic journal in Korean, which is 화학공학 in Korean. Now it is published bi-monthly. And also they started the first educational program for industrial people in 1963. And also they established a regional section to cover the members in all areas of Korea. The Busan and Gangnam regional section was the first one established. It was established in 1964. And then the first newsletter was published in 1969. And then in 1983, KICHE hosted this Project 3, which is the Pacific Chemical Engineering Conference, hosting about more than 1,000 participants and about 260 papers from this Asia-Pacific zone. This event upgraded the position of this KICHE a little further, so that the chemical engineers of Korea are well known in this area, and they started a vigorous program to promote the academic activities of chemical engineers in Korea. And in 1984, the Korean Journal of Chemical Engineering, which is published in English, was first published. It started as a biannual, but now it started twice in a year. But now it is published every 2 months, so it's bi-monthly. Can I have the next one, please? In line with this expansion of the KICHE, I think you probably saw this picture in the English brochure that was distributed at the registration desk. We have, the KICHE has 4 regional sections all through this Korea, the South Korean area. Can I have the next one, please? And also we have about, say, 10 committees to promote the activities of the members. Particularly, I would like to draw your attention to the Committee of Women Chemical Engineers, which was established 2 years ago in the year 2000 to promote, to encourage the participation of the women chemical engineers in this institute. Have the next one, please. And also, the activities of the members are divided into many special divisions. The KICHE has 13 divisions at the moment, covering biochemical engineering, catalysis and reaction engineering, energy and environment, and food isolate, and so on. Almost all the areas of chemical engineering are covered by these divisions of KICHE. Can I have the next one, please? Also, as I said, KICHE publishes 3 periodicals. One is for the members, for circulation to the members, and it publishes 2 academic journals, one in English and the other one in Korean. Also, it published many books to promote the activities of the members, as well as to make this chemical engineering discipline well known to the Korean society, especially to the industrial people. So I published Chemical Industries in Korea in 1982, which covers most of the chemical engineering industries at the moment. And then it was revised in 1992 and was published under this name. And recently, about 4 years ago, we recognized that the discipline of chemical engineering is facing a new challenge. So we felt that we should consider about the future directions of this chemical engineering discipline. So we formed an ad hoc committee to study about the future of the chemical engineering. And these 2 books are the results of the activities of this ad hoc committee. One was about the missions of chemical engineering in industry, and the other one was vision of chemical engineering, chemical technology, and chemical industry in Korea in the 21st century. And also it published a few proceedings that KICHE have hosted so far. The most recent one is the one held in 1999, which was 8th APCHE Congress, which APCHE is for the Asia Pacific Chemical Engineering Congress. Can I have the next one, please? In parallel with this kind of aggressive or very vigorous activity of the KICHE, the education of chemical engineering at universities were also expanding. This table shows how many chemical engineering departments are in Korea. Korea has 75 engineering colleges, Among these 75 engineering colleges, 55 have chemical engineering departments, and the professors at these departments are close to about 400, and the undergraduate students educated at these universities are close to about 3,500 students. This is excluding the departments which are closely related to chemical engineering discipline, such as the Department of Chemical Technology and the Department of Polymer Engineering and Environmental Engineering. So covering all these related departments, the number of departments increased even more, and the students graduating from these departments are much larger in number than this 3,500. So this may be regarded, depending on the individuals, this may be regarded as too many departments or too many students are produced, or other individuals may think that we're still short of the number of the students produced. But it depends on the demand from the industry. Can I have the next one, please? Together with this expansion in education, the chemical industry of Korea was also expanding, as I said. This is a table showing the demand and supply of petrochemical products in Korea since 1997. This is a projection for the future. In 1997, Korea produced about 12 million tons of petrochemical products. Out of this 12 million tons of products, about 4 to 5 million tons has to be exported because the Korean market cannot consume all of this production, and the situation becomes even worse or greater, whatever you may say. By the year 2003, we have to export about half of the production of the petrochemical products, mostly, presumably to the Chinese market. Actually, that was one of the incentives to expand the petrochemical industries of Korea in such a vigorous way, because industrial people expected that the Chinese market will expand very rapidly, and Korea can play the role of a major supplier of these petrochemical products to the Chinese market. Anyway, this is the situation in Korea now. So we have somewhat oversupply of the chemical and petrochemical products in Korea. Have the next one, please. Similar situation is observed in this table. That we have overproduction, and another factor to be considered with the petrochemical industry of Korea is that the capacity of the plants is relatively small compared to those of other countries. For example, in the USA, the capacity per company of the ethylene production is about I think it's 1 million tons per year, whereas in Japan it's 640 kilotons per year, and Korea is playing with the smallest plants. Still, it has an oversupply of the product. So you may well know that the economy of this petrochemical plant is very closely related with the capacity of the production. So this table tells us that we are not so much competitive in the economy, in the production economy of the petrochemicals. Yeah, the next one, please. Contrary to the change in the petrochemical industry of Korea, other industries, for example, the semiconductor industry of Korea, is expanding very much, and still remains very competitive in the international market. Can I have the next one, please? Yeah. So this is one of the articles in Economic Journal of Korea, which tells that Samsung and Hyundai is the former name of Hynix Semiconductor. Samsung and Hyundai are competing for the first position in the semiconductor industry of the world. So Samsung and Hyundai were very much competitive, and they were making very good business in the international market, which is very contrasting to the situation of the chemical, especially the petrochemical industry of Korea. Can I have the next one, please? So this kind of trend has been reflected to the job market of the chemical engineers who were educated in Korea. This table shows that the distribution of chemical engineers by their employment, by their jobs. And fine chemicals and petrochemicals are the major job markets for chemical engineers, which is obvious. But it is interesting that many chemical engineers are getting jobs in electronics and information industries, as well as machinery or automobile companies. So, the old tradition that the chemical engineers usually move to either refinery or petrochemical companies is changing. A large portion of the people are moving to industries other than this, say, the traditional chemical industry. So this is a trend. Can I have the next one, please? So, what should be our response? What should be our measure for this kind of change? One action, especially at the university, is the merger of many similar departments. I listed the name of departments of Korea at universities which are very similar to each other. Industrial chemistry, fine chemistry, and so on. There are so many similar departments, and the recent action is that they are trying to merge together so that they form a critical mass in education as well as in research. Have the next one, please. Another action is starting a new program. This is one example of the new curriculum started at the Department of Chemical. It used to be Chemical Engineering Department, but they added the new name, Biomolecular Engineering. This is at KAIST. So you see new words that was not quite popular in the old chemical engineering area: bio, nano, molecular, and microsystem. So this is another trend, another action that some of the departments of chemical engineering are taking for the future. Have the next one, please. So in conclusion, I would like to propose the following directions for each of these sectors that are forming the chemical engineering in Korea. First, for the industry, they are already taking this principle. They are taking the selection and focusing. They're not going to take all the areas of industry, but they are selecting only a few competitive areas and then trying to focus on those areas so that they produce more high value-added products as well as processes. And in that course, I feel, this is my personal feeling, that industries that are at interface between the traditional chemical industry and other industries such as microelectronics or automobiles or medicine, the industry at the interfacial area is becoming more and more important. And there is a very high opportunity that these industries will make a good profit in the future. And the next one, please. For the university, as I said, there is already an action to merge all the similar departments together so that they form a critical mass either in education or research. So they are starting new curriculum and educational programs, and even they are changing their names so that they have a new image to the public. And next one, please. Based on all these changes in industry and university, as I said, the KICHE cannot be explained independently from the changes at universities or industry. I believe the KICHE should also change in the future. The key word for the change in the future for KICHE maybe, in my personal view, is academia-industry cooperation. The institute should stay in a very close contact with industry so that they can adapt themselves to the changes made at industry. And so this should be the key word for the future. And in that course, I believe the hybridization, in other words, the mixing of all different disciplines, such as mixing of the traditional chemical engineering with, say, electronics, or medical engineering, or other areas, even physics, chemistry, and biology, and those. Such a multidisciplinary program should be established and expanded in the activity of this KICHE in the future. This is my proposal and concludes my talk. Thank you very much.